Hello students, in this video we're going to solve some challenging O-level questions on the topic area under the curve. Do get ready a pen and some papers and practice along with me. Right, let's look at the first question, which is from the year 2021. So the diagram shows the curve y equals to 4 sine x over 2 minus x for x to be between 0 and pi radians inclusive. That's a point M, and this point M is a maximum point on the curve, and we are told that OM is a straight line. We are asked to find, or rather, to show the area of the shaded region, shown as orange color. It's given to be 4 minus 2 pi square root 3 over 3. So the key words are, yes, M is a maximum point. So when we are talking about maximum or minimum point, we're referring this point to this thing called the stationary point. And for stationary point, the concept involved here is we let the gradient equals to 0. For that, we will have to differentiate 4 sine x over 2 minus x. So differentiating sine x over 2, I will get cosine x over 2. And not to forget, I need to differentiate x over 2. Differentiating x, you get 1. And x over 2 is the same as x over 1 times 1 over 2, which has the same meaning as half x. So differentiating half x, we get a half. And 4 times half will give me 2. That is how I end up having 2 cos x over 2 minus 1. And we're going to let this value equals to 0 so that we can find the x coordinates of your point M. Right, so to solve this trigo equation, let's find your reference angle alpha, which is cosine inverse half. And that gives you pi over 3. Now there are some other values. So they give us pi over 3. So we will have x over 2 equals to pi over 3. And therefore, x is 2 pi over 3. So because the x coordinate of M is the first, right, if you were to recall for your ASTC, there are other values then. There are other quadrants for cosine to be positive, first and the fourth. But we don't have to worry about getting the angle from the fourth quadrant, because if you look at the diagram given, we just need to worry about the first value we get for x, which is 2 pi over 3. Right, so the next thing we need to do is, having found the x coordinate for point M, we would have to substitute it into the equations of the curve, which is y equals to 4 sine x over 2 minus x, to find the y coordinates. And if you look at what you're supposed to show, right, you can see that you're supposed to leave your answer as exact value. So therefore, for sine pi over 3 at 60 degrees is a special angle. So therefore, you have to leave it as square root 3 over 2. So this is the y-coordinates for point M. And why do we need the y-coordinate for point M? Because to find the area of the shaded region, yes, we would have to find the area under the curve this is called area under the curve, minus away the triangle area, minus away the area of the triangle. To find the area of the shaded region, we have to find the area under the curve, minus away the area of the triangle OMZ. So this is what we're going to do. So to find area under the curve from 0 to 2 pi over 3, we need to integrate 4 sine x over 2 minus x and to take limits from 0 to 2 pi over 3. And area of the triangle OMZ will be half times OZ, which is basically the x coordinates of point M, 2 pi over 3, and MZ, which is basically the y coordinates of point M. That is the reason why we need to find the y coordinates of point M. Alright, so to integrate sine x over 2, we will have integrating sine, we have a negative cosine x over 2, and integration is different from differentiation. Instead of multiplying with the differentiation of x over 2, we actually divide it with the differentiation of x over 2. So that will give us negative cosine x over 2 over half. And that gives us negative 2 cosine x over 2. This will be negative, this will be negative 2 cosine x over 2. And not forgetting I have a 4 here. So 4 times negative 2 will give me a negative 8 here. Alright. So the next thing is, yes, integrating x, you will get x squared over 2. So the next step is to substitute in the limits. And let's simplify this first. Right, that will give us half times 2 pi over 3 times this will give you negative 2 pi square root 3 over 3. And negative half times this times negative 2 pi over 3 will give you 2 pi squared over 9. Okay, let's sub in the limits. So x over 2, when you sub in your x to be 2 pi over 3, you have 2 pi over 3 times half. That gives you pi over 6. And cosine pi over 6 is, that gives you pi over 3, wrong. And cosine pi over 3, it's cosine 60 degree, which gives you half. Let's explain the half there. And substituting your x to be 2 pi over 3, you will have 2 pi over 3 times 2 pi over 3 divided by 2. That gives you 4 pi squared over 9 divided by 2 means times half. That gives you 2 pi squared over 9, and that explained this answer here. Right, let's simplify further. And you will see that we will end up with the answers that we're supposed to show. So in these questions, the concepts involved here are using letting dy dx equals to 0 while finding stationary point, and special angle, sine 60 is square root 3 over 2, cosine 60 it's half. Yes, of course, differentiation of sine, integrating, yes, differentiation of sine and integrating of sine. So these are the concepts involved in this question. Let's look at the next O-level questions. This is from the year 2018. It's also a very interesting question. In these questions here, it combines with the concepts of tangent and normal line. So we are given a curve, and then PT is a tangent line, and NP is a normal line. So therefore, this angle NPT is 90 degrees. Right. So we're given some points there. X has coordinate negative 5, 0. Sorry, N has negative 5, 0. X has 7 over 3, 0. Given point P to be K, 2 square root 7 minus 3K. We're also given the equations of the curve, which is y equals to 2 square root 7 minus 3K. So for part I, we are asked to prove that K is equals to 1. So what are the concepts involved here when we are told that PT it's a tangent line and PN it's a normal line? Right. So let's do a recap. For tangent line, how do we find the gradient of the tangent line? Yes, the gradient of the tangent line will be your dy over dx. Right, so the first thing we need to do is to differentiate 2 square root 7 minus 3x. And we're going to convert the radical form, this is called the radical form, into the index form. And we're going to differentiate it. Right, so you just keep your 2, bring the half to the front, keep this, power minus 1. So half minus 1 gives you negative half, and differentiate whatever that's inside the bracket. So differentiate 7 get 0, differentiate negative 3x get negative 3. So this is what we have where we differentiate 2 bracket 7 minus 3x to the power half. So that simplify. So I would have 2 times half give me 1 times negative 3 gives you negative 3. And put it back in radical form. This means 1 over 7 minus 3x to the power half means 1 over square root 7 minus 3x. Okay, I'll explain why is it easier to deal with the value in radical form. So that is the gradient, okay, that's the gradient of a tangent line PT. That is the gradient function, I'm sorry, that's a gradient function. So the gradient of the line PT is when I substitute my x to be k. So the normal, okay, the gradient of a normal line at P, if you were to recall, the gradient of a tangent line multiplied with the gradient of your normal line must give you negative 1. That's why they're perpendicular to each other. So to find the gradient of a normal line, it's just negative 1 divided by the gradient of your tangent line. So it's just negative 1 divided by this value. And that's what I mean by it's easier to deal with expression in radical form. So negative and negative you can cancel off. So change the division to time. Flip it. So the gradient of the normal line at point P would be this value. Okay, we're going to keep that. And if you look at what we are given for this line NP, which is our normal line, I'm given this point and I'm given this point P. So I can use another way to find the gradient of this line Pn using y2 minus y1 over x2 minus x1. And these two gradients are equal to each other. These two values are equal to each other. So we can basically equate them. And we are told that k is less than square root 3 over 2. So that makes if k is less than k is less than 7 over 3. What's wrong with me today? We're told that k is less than 7 over 3. So that makes square root 7 minus 3k a positive value. Okay? So we can just ignore this. No, it's not ignore it. We can just divide it on both sides with square root 7 minus 3k. And we end up having 1/3 equals to 2 over k plus 5. And we do some cross multiplication, and you will get k equals to 1. All right, maybe I can do a little bit explanation why k less than 7 over 3 will give me this. So k less than 7 over 3, we're going to multiply by 3 on both sides. Multiplying by 3 on both sides is all right because it's a positive value. And then we're going to multiply by both sides with negative. So when I do that, then I have to flip the inequality sign. And then I'm going to add 7. Adding 7, it's all right. And you can see that this is why we will end up having 7 minus 3k more than 0. So of course, square root of 7 minus 3k will also be more than 0. Right, let's erase this. Okay, so here we have found that k is equals to 1. Then for part 2, having found k is equals to 1, obviously we're going to substitute into a point P. We have the x coordinate to be 1, the y coordinate to be 4. And of course, we can also substitute in to find the gradient of our tangent line. So this is gradient of our tangent line. That's better. Let's write it. Gradient of tangent line, PT. All right. Okay, so what's the next thing we need to do? We're asked to show that the x coordinate of t is 11 over 3. So we're asked to find the x coordinate of point T. So to do that, we need to find the equations of the line PT. We need to find the equations of the line PT. That's why we need a point and we need the gradient. Okay, so using this, y minus y1 equals to m bracket x minus x1, where your x1, y1, it's your point P 1, 4. Your gradient is negative 3 over 2. Right. You end up having y equals to negative 3 over 2x plus 11 over 2. So to find the x coordinates of point T is when I let y equals to 0. And that's how I get x equals to 11 over 3, which is what I'm required to do in part 2. All right, so in part 3, we're asked to find the area of the shaded region. All right, so the area of the shaded region is area of this triangle here, PYT, minus away the area under the curve from x to t. Sorry, minus away the area under the curve from y to x. This is area under the curve, this part here. Right, so we are finding the area of the triangle PYT, which is a right angle triangle. So you can use half base times height minus away the area under the curve. This is called the area under the curve, this one. Bounded by the curve, bounded by py, bounded by yx. All right, so the y coordinates, the x coordinate for point y will be 1. The x coordinate for point x is 11/3. Sorry, the x coordinate for point x is, have we found it yet? 7/3. You're told here. And the x coordinate for point T is 11/3, found in part 2. All right, so with all this x coordinate, okay, we're able to find what we need to do. So the area of the triangle will be half times base. So it's the difference of from 11/3 minus 1. The height here, which is the y coordinates of point P, which found earlier on to be 4. And of course, area under the curve, we need to integrate from 1 to 7/3 to square root 7 minus 3x. Okay, so this one here, you can write it as 2 bracket 7 minus 3x to the power half. Right, so half plus 1 will give you 3/2. Divide by differentiation of this, which is -3, and also divide by the power. Okay, not to forget, divide by the power, divide by the differentiation of 7 minus 3x, which is -3. Okay, so we can substitute in oh, it seems that I repeat the same thing. Same. Never mind. All right, so let's substitute in x to be 7/3. Right, so I'm going to do this for you. So that will be, if you substitute your x to be 7/3, 3 times 7/3 will give you 7. So 7 minus 7 will be 0. Anything times 0 is 0. So the first value here is 0. Then the next is minus away. When I substitute my x to be 1. So substitute x to be 1. 3 times 1 will give me 3. So that's how I end up with this. And basically, you just use a calculator to work this out. Just use a calculator. 0 minus away the fraction. Use the fraction. Then 2 bracket 7 minus 3 close bracket to the power 3/2. Bring your cursor down to fraction again. 3/2 bracket -3. So if you do it carefully, all right, you would get 32/9. So this will be 16/3 minus 32/9. And that will give me 16/9. So therefore, the area of the shaded region is 16/9 units square. Right, the next questions we're going to look at, it's a different kind of questions. But this is not O-level questions. It's a questions from the assessment book. Let's see how different it is. Right, in these questions here, you're given the curve y equals to a cos 2x. Yes, so the difference concerning these questions from the previous one, it's you're given the unknown a here. A, it's an unknown value. All right, so we asked to find the values of a. Right. So let's do a recap on your cosine curve. Right, so this is a cosine curve. This is y equals to cosine x. So for y equals to cosine x, the period is 2 pi. maximum, minimum y value, it's 1 and -1, right? So the minimum value of y equals to cos x happen at x equals to pi. Okay, so what we need to do is to find the period for y equals to a cos 2x. So to find period, it's taking 2 pi or 360 degrees. In this case here, we're using 2 pi divided by the coefficient of x. Here is 2. Coefficients of x. In this case, is 2. Right. So the period is pi. So if the period is pi, you will see that the lowest point here, to get the minimum y value, the x coordinate will be, instead of pi, it has to be pi over 2. Right, because now your period is shrunk from 0 to pi. So therefore, if you do a comparison with y equals to cos x, then it's no longer pi giving you -1. It's pi over 2 gives you your minimum y value. And of course, your minimum y, if you look at this line that you're given, y equals to 2, your maximum y value is 2, so your minimum y value will be -2. Right, so A represent, so this is your upright cosine curve, this upright cosine curve, so therefore A is a positive value, so A is equals to 2. The amplitude is 2. But this is the upright curve, so A is 2. If this is an inverted curve like that, then of course your A will be -2. Okay, so this is how we do part I. So for part 2, we asked to find the x coordinate of B and C. All right. So if you were to refer back to your basic cosine curve, this is when the value of x is pi over 2. So now your period is from 0 to pi, right? So you need to take pi over 2 divide by 2. So the x coordinate of B is pi over 4. And this value here is 3 pi over 2, right? But now your period is between 0 to pi. So we need to take 3 pi over 2 divided by 2. And that gives you 3 pi over 4. Okay, so this is what I mean by a different kind of questions, very interesting questions, where you can actually make use of your basic curve y equals to cos x to find the unknowns. All right, so we are done with the part I and 2. Right, sorry, this is part 2. So now let's go on to do part 3. Right, so that's having found the values of A, we can just plug this in to give us y equals to 2 cosine 2x. So this is 2. All right, so let's put in the x coordinate of point B, pi over 4, x coordinate of point C, 3 pi over 4. Right, so this is a slightly different question from the earlier on. Why? Because I do have a region that is below the x-axis. Right, so I'm going to divide this shaded region into 2 parts, finding the area of region A, and then find the area of region B, and then add these 2 values together to find the area of the shaded region. So let's look at how we find the area of region A first. So to find the area of region A, we need to find the area of this rectangle. Okay, then minus away the area here. This is called area under the curve, bounded by the curve, the y-axis and the x-axis. So area of the rectangle will be just base times height. So basically it will be just, this one is your base, which is 3 pi over 4. The height is 2. Okay, so that is area of your rectangle. It's easy. Then minus away the area here of this curve, which is we have to integrate from 0 to pi over 4, 2 cosine 2x. All right, so integrating cos 2x, okay, just ignore the 2. But integrating cos 2x will give you negative sine, positive. Integrate cos give you positive, okay? Integrate cos 2x will give you sine 2x, then divide by differentiation of 2x. So it's just sine 2x divided by 2. Not forgetting there's a 2 there, right? So you simplified it, you end up with sine 2x, okay? Then of course you sub in your limits. Sub in your x to be pi over 4. Pi over 4 times 2 is pi over 2. Sub x to be 0. So sine 90 will give you 1. This will be 1 minus 0. That gives you 1. Okay, so that is area of region A. We're going to keep it. Don't touch it. Now, area of region B is a bit tricky because it's below the x-axis. We need a negative. Because when you integrate something that's below the x-axis, we get a negative answer. But area cannot be a negative answer because this value will be negative. So I need to multiply with the negative so that I can get a positive answer for area. Okay, right. So I need to integrate 2 cos 2x, which is equals to sine 2x here. I've already done it early on here, right? So you just plug in the values for x. So this will give us sine 2x, right? Plug in the values of x, so there will be sine 2 times 3 pi over 4. That gives you 3 pi over 2. Plug in 2 times pi over 4. That gives you pi over 2, right? So sine 3 pi over 2 is negative 1. And sine pi over 2 is 1. So negative 1 minus 1 gives you negative 2. Negative 2 times the negative here, that gives you 2. Okay, right, and then I'm going to add both of them together. Right, area of region A is 3 pi over 2 minus 1 plus area of region B 2. So the total area is 5.71 units. We are not asked to leave the answer as exact. If the question says leave your answer as exact, then your answer will be 3 pi over 2 plus 1. Here the questions says that correct the answer to 2 decimal places. So we leave it as 5.71. Okay, so that ends the whole video. Happy learning.